The United States Navy operates the most capable submarine force on Earth. 70-plus hulls, nuclear-powered, globally deployed, armed with Tomahawk cruise missiles and Mk-48 torpedoes. The price tag for a single Virginia-class attack submarine runs to roughly $3.5 billion. Congress has funded the program. Contracts are signed. The demand signal from AUKUS alone requires a sustained output of more than 2 boats a year just to keep the alliance commitments alive, before a single hull goes to Australia. So here is the number that stops everything cold: 2. That is the rate, not 3, not the stated goal. Roughly 2 Virginia-class submarines per year, and in several recent years closer to 1.2 or 1.4 when delays compound. The Navy has the money, the blueprints, the political will, and a strategic argument that is getting louder every year as Pacific tension rises, and yet the production line does not move. The question this raises is not rhetorical. If the largest defense budget in the world cannot accelerate submarine production, what is actually holding the line? The answer turns out to be something no appropriations bill can fix overnight, something that cannot be ordered into existence by a White House deadline or a SECDEF memo from Pete Hegseth. Stay with this, because the answer rewrites what you think you know about industrial power. To understand the weight of 2 boats a year, you need to understand what a Virginia-class submarine actually is. The Block V variant, the current production standard, displaces around 10,000 tons submerged. It carries the Virginia Payload Module, a mid-body insert that adds 4 additional large-diameter payload tubes, bringing total Tomahawk capacity to roughly 65 missiles per hull. It runs on a single S9G reactor that never needs refueling over the life of the boat. Its acoustic signature, across decades of engineering refinement, sits below the ambient noise floor of the ocean in most tactical frequency bands. It can operate independently for months, track surface groups, strike land targets, lay mines, support special operations, and hold anything that floats or flies at risk from distances the target cannot reach back. There is nothing in the world that matches a Virginia-class submarine on a capability per hull basis. Not the Russian Yasin-M, not the British Astute. Certainly not a Chinese Type 039 diesel-electric boat, which is quieter in port than at sea, and whose endurance is constrained by battery capacity and the need to snorkel. The Type 039 exists to operate in coastal and littoral water, to complicate the first few hundred miles of any approach to the Chinese coast. A Virginia-class submarine exists to operate anywhere on Earth, undetected, for as long as the crew can sustain it. That distinction is the foundation of the entire production paradox. The 2 primary production facilities for Virginia-class submarines are General Dynamics Electric Boat in Groton, Connecticut, and Quonset Point, Rhode Island, and Huntington Ingalls Industries Newport News Shipbuilding in Virginia. These are not interchangeable factories. They are among the most complex manufacturing environments in American industry, containing some of the only workers in the country who know how to weld HY100 and HY130 high-yield steel to the tolerances a pressure hull demands. The hull sections are built at multiple sites, mated at the yards, and the integration work, piping, cabling, reactor installation, weapons systems, runs to millions of individual work hours per boat. The 2 yards share production of each hull. That arrangement was designed to sustain both industrial bases simultaneously, because if one yard atrophies, if the workforce disperses, if the specialized tooling degrades, reconstituting it takes not months but decades. The Navy learned this lesson the hard way after the post-Cold War drawdown of the 1990s, when shipyard capacity contracted sharply, and the cost of rebuilding the workforce base proved far higher than the cost of maintaining it would have been. What struck me going through the Government Accountability Office assessments and the Congressional Budget Office projections on this program is a single detail that keeps resurfacing across multiple reports spanning more than a decade. The bottleneck is never the reactor components. It is never the combat system. It is never the hull steel. It is the people who join it all together. The skilled trades shortfall at Electric Boat and Newport News Shipbuilding is not a rumor or an estimate. Pentagon planners and congressional testimony have put a concrete figure to it. Somewhere above 20,000 positions across the 2 yards and welders, pipe fitters, electricians, and machinists. The specific categories of trades that submarine construction demands. These are not jobs that can be filled by retraining a software developer or cross-training a worker from an automotive plant. The welding certification for submarine pressure hull work requires years of qualification. A welder who joins the program today will not be fully productive on the most demanding submarine work for 3 to 5 years. That timeline cannot be compressed by paying more. It cannot be shortened by signing a bigger contract. Both yards are actively recruiting and have been for several years. Electric Boat has opened training centers, partnered with community colleges, offered signing bonuses, and expanded its apprenticeship programs. Newport News Shipbuilding has run similar initiatives. The workforce is growing, but it is growing against a base that was already stretched thin and against the compounding demand signal from AUKUS, which is itself a structural commitment that runs for decades. Here is the part that does not make sense on the surface. The United States has spent more than $40 billion on Virginia-class production since the class entered service. Congress has repeatedly authorized multi-year procurement packages, the kind of long-term commitment that should, in theory, give the yards confidence to invest in capacity. And yet the throughput number has barely moved off too. The reason is that capital investment in a shipyard and workforce growth are not the same thing. You can build a new assembly hall. You can buy additional tooling. You can expand the dry docks. None of that produces a certified submarine welder in year one. The physical infrastructure follows the workforce, not the other way around. And the workforce follows a 5-year training curve that no budget cycle can shortcut. The stated goal has been consistent for years. The Navy wants 2 Virginia-class submarines per year as a floor, with a ramp toward 3 to meet AUKUS obligations. The reality, tracked through delivery records, has been closer to 1.2 to 1.4 in years where supply chain disruptions or workforce shortfalls cascaded through the schedule. A submarine delivered 6 months late is not just a scheduling inconvenience. It is 6 months of reduced Pacific presence, 6 months of deferred rotation for crews already running high operational tempos, 6 months of a hull that AUKUS planners were counting on not being where the Alliance expected it. This is the moment where a second layer of the problem becomes visible. The AUKUS submarine arrangement, announced in September 2021 by President Joe Biden alongside the Australian and British governments, commits the United States to eventually providing Australia with nuclear-powered attack submarines. The pathway runs through a rotational presence of U.S. submarines at HMAS Stirling near Perth, then the transfer of up to 5 Virginia-class boats to the Royal Australian Navy beginning in the early 2030s, pending congressional approval, with British SSN AUKUS hulls following later in the decade. The arithmetic of this commitment is unforgiving. To sustain the U.S. force structure, meet the rotational presence requirements, and transfer hulls to Australia, the production rate needs to exceed 2 boats per year, not eventually, but consistently, beginning now. At 1.4 boats per year, the numbers simply do not work. The Alliance absorbs boats that the Pacific Fleet would otherwise retain, and the Pacific Fleet absorbs an operational tempo that its crews and maintenance schedules were not designed to sustain indefinitely. Put yourself in the position of a U.S. Pacific Fleet planner for a moment. You have a fixed number of Virginia-class and older Los Angeles-class hulls. The Los Angeles boats, submarines like USS Tucson and USS Columbus, are aging out of service at a rate that Virginia production is only partially keeping pace with. The net operational submarine count available to Pacific Command is not growing at the rate the strategic environment demands. Every hull that goes to Australia, every hull that sits in extended maintenance, every hull that misses its delivery date by 6 months narrows the window of available presence in the Western Pacific. Now hold that operational pressure alongside the economic asymmetry, because this is where the rival's strategy becomes visible as a number rather than a headline. A Virginia-class Block V submarine costs approximately $3.4 billion per hull. A Chinese-type 039 diesel-electric submarine, the workhorse of the People's Liberation Army Navy submarine force, carries an estimated unit cost of between $350 and $500 million, depending on the variant and the cost accounting method applied. That is roughly a 6-to-1 or 7-to-1 price ratio per hull. The Type 039 is not a Virginia-class competitor in open ocean capability. It does not have the endurance, the acoustic performance, or the weapons payload. But that is not the strategic question Beijing's planners are asking. The question they are asking is whether a large number of capable enough submarines, operating within the first and second island chains in waters they know well, can complicate the operational calculus for a U.S. force that is constrained by production throughput and operational tempo. A Type 039 does not need to defeat a Virginia-class submarine in a one-on-one engagement. It needs to be numerous enough and positioned well enough to force the U.S. Navy to account for it across every contingency plan. The People's Liberation Army Navy has been building submarines, Type 039, Type 093, and developing the Type 095, at a rate that outpaces the U.S. in raw hull count. The U.S. leads decisively in per-hull capability and in the ability to operate globally. China leads in regional concentration and in the ability to generate tactical complications within a defined geographic space. These are not the same competition, and treating them as if they were produces exactly the wrong conclusions about where the bottleneck matters most. What strikes us about this production problem is that it is not a story about American decline. It is a story about what happens when you optimize a defense industrial base for a post-Cold War world, one defined by precision over mass, by technology advantage over numerical parity, and then discover that the strategic environment has shifted back toward a world where numbers matter again, and where reconstituting mass production takes longer than anyone budgeted for. The supplier-based problem runs parallel to the workforce problem, and it is almost as difficult to resolve quickly. A Virginia-class submarine contains components from hundreds of suppliers: specialized valves, pump systems, reactor components, acoustic dampening materials, fire control elements, combat management hardware. Many of these suppliers are sole source providers. There is, in some cases, one company in the United States that manufactures a specific valve or fitting to the tolerances submarine construction requires. When that supplier falls behind schedule, due to its own workforce constraints, its own materials costs, its own capacity limits, it creates a ripple that propagates through the entire integration timeline. The Navy and the yards have been working to qualify second sources for critical components to reduce sole source dependency and to build more buffer inventory into the supply chain. These are sensible responses, but they take time to implement and cost money to sustain. Qualifying a new supplier for a nuclear-rated component is not a process measured in months. Here's a detail that has stayed with me from the congressional testimony on this. In one GAO review, auditors identified more than 40 submarine components where the U.S. had a single qualified supplier with no approved backup. 40 components, any one of which, if it missed a delivery window, could cascade a delay across an entire hull. The Navy knew about most of them. The challenge was not awareness. It was the structural difficulty of building redundancy in a market too small to support multiple competitors for some of these specialized parts. The budget picture adds a layer of irony that reinforces the paradox. Congress has not been unwilling to fund submarine production. The FY 2024 and FY 2025 defense budgets included significant funding for Virginia-class procurement, for shipyard infrastructure investment, and for workforce development programs. The chips and industrial-based conversations that followed the pandemic sharpened political appetite for domestic industrial investment. And yet appropriated money and delivered submarines are two different things, separated by a 5-year construction timeline and a workforce training curve that begins on the day a new hire walks into the apprenticeship program. The money authorized today does not appear as a submarine next year. It appears, if everything goes well, as a submarine in 2029 or 2030. That lag between investment and output is intrinsic to the production process. It cannot be engineered away. It can only be acknowledged and planned around, which means the decisions that determine 2030 submarine availability were made in 2025, and the decisions that will determine 2035 availability are being made now. This is the part that should make anyone rethink what industrial competition between great powers actually looks like in the 21st century. So where does that leave the production line today? And what are the options actually on the table? The first path is sustained investment in yard expansion and workforce development, accepting that throughput will remain near 2 boats per year for the next several years, and only approach 3 in the early 2030s if the workforce ramp works as projected. This is the path of strategic patience. It preserves the quality advantage, maintains the capability edge that makes each Virginia-class submarine worth multiple competitors in a real-world engagement, and eventually delivers the AUKUS commitments. Just on a slower timeline than the alliance originally modeled. The cost is a thinner Pacific submarine presence in the near term, higher operational tempo for current crews, and a gap in the rotational presence at HMAS Sterling that Australia will notice. The second path is to accept 2 boats per year as the durable ceiling for the foreseeable future, optimize the operational availability of the existing fleet, reducing maintenance backlogs, accelerating refueling cycles for older boats, extending deployment lengths where crews can sustain them, and lean harder on the submarines already in service rather than waiting for new deliveries. The risk here is maintenance deferral compounding over time. A submarine deferred from its scheduled maintenance period does not become more reliable. It becomes a larger maintenance problem the next time it enters the yard, and it drives the yards further into competing priorities between new construction and repair. There is a third path that does not appear in official planning documents but is visible in the strategic logic: reducing the AUKUS transfer commitment or slowing its timeline to preserve more hulls for the U.S. Pacific Fleet in the near term. This is politically costly. It would require renegotiating commitments with Canberra and London, and it would undercut the signal value of AUKUS precisely when that signal is doing strategic work in the Indo-Pacific. But the arithmetic is real, and planners who work these numbers privately acknowledge that the gap between AUKUS demand and production capacity is not closing fast enough to make the current timeline comfortable. What none of these paths can do is conjure a certified submarine welder in less than 3 years, or qualify a new sole-source supplier in less than 18 months, or compress a 5-year hull construction timeline into 3 by spending more money. The constraints are physical and human, not financial. That is the reversal at the heart of this story. The United States Navy is not capacity constrained by budget. It is capacity constrained by time. Specifically, by the time it takes to build the human and industrial infrastructure that budget can fund but cannot replace. Here is what that means in operational terms. A Virginia-class submarine like USS Delaware or USS Montana is a strategic asset the size of a city block, capable of holding at risk everything the adversary floats in the Western Pacific. When that asset is delayed by 6 months because a specific valve supplier missed a delivery, or because a certified welder left the yard for a higher-paying job in the energy sector, and the replacement welder will not reach full qualification for 4 years, the gap is not filled by a budget supplement. It is filled by running the existing fleet harder, extending deployments, and deferring maintenance. That operational pressure is measurable. Crew retention surveys at the Submarine Force have tracked the relationship between deployment tempo and retention for years. Longer deployments, shorter interdeployment periods, and maintenance periods that slip mean crews spend less time at home and more time at sea or waiting in yards. The Submarine Force has some of the highest technical qualification requirements in the military. Losing an experienced sonar technician or a reactor operator to burnout or a civilian job offer does not just affect morale. It affects the operational availability of the hull that crew member was assigned to. Here is the take that will probably draw some disagreement. The AUKUS timeline as originally modeled was optimistic in ways that the production data available in 2021 should have flagged more clearly. The commitment to transfer up to 5 Virginia-class submarines to Australia in the early 2030s was made against a production baseline that was already showing stress. The strategic rationale for AUKUS is sound. A nuclear-powered Australian submarine force operating in the Indo-Pacific changes the calculus for any adversary planning around the first and second island chains. But the production timeline implied by the original agreement required a ramp from roughly 2 to 3 boats per year that the workforce and supplier base were not, and are not, positioned to deliver on that schedule. Acknowledging that is not a criticism of the alliance. It is a recognition that industrial commitments made in press conferences have to eventually survive contact with the production floor. The steps being taken to close the gap are real. Electric Boat's workforce has grown significantly since 2021, with thousands of new hires moving through the apprenticeship pipeline. Newport News Shipbuilding has invested in expanded training facilities. The Navy's industrial base investment programs have directed funding towards supplier qualification and second source development. The FY 2025 budget included specific line items for shipyard infrastructure that will expand physical throughput capacity at both yards over the next decade. What would you do if you were running this program? Hold the AUKUS timeline and accept the operational risk of a thinner near-term Pacific force, or push back the transfer dates and absorb the diplomatic cost? Drop your answer in the comments. The range of positions people hold on this is wider than you'd expect, and it is a question that does not have a clean answer. The rival side of this equation deserves a clear-eyed accounting, because the comparison is often made in ways that generate more heat than light. China's shipbuilding capacity, measured in gross tonnage, is the largest in the world. The yards at Jiangnan, Dalian, and Hudong-Zhonghua are building surface combatants, Type 055 destroyers, Type 052D destroyers, and the Fujian carrier, at a pace that U.S. naval planners track closely. In submarine construction, the numbers are harder to confirm precisely from open sources. but the trend lines and available intelligence assessments point to an output rate that exceeds U.S. submarine production in raw hull count. The important caveat is that raw hull count and operational capability are not the same metric. A Type 039 diesel-electric submarine is a capable platform in its intended operating environment: the near seas around China, the South China Sea, the waters approaching Taiwan. It is not designed to shadow a carrier strike group in the mid-Pacific or operate undetected for 3 months in the Indian Ocean. The People's Liberation Army Navy submarine force is built for a different strategic function than the U.S. attack submarine fleet, and evaluating it by Virginia-class standards produces a distorted picture in both directions. It underestimates the threat in the near-sea environment and overestimates it in the open ocean competition. What is not distorted is the trajectory. The planned surface and subsurface force has grown more capable, more numerous, and more operationally experienced with each passing year. The Type 055 destroyer, a surface combatant that carries over 100 vertical launch cells, represents a significant capability jump from earlier Chinese surface combatants. The Fujian carrier, the first Chinese carrier equipped with electromagnetic catapults, represents a generational step in carrier aviation capability that, when its air wing matures, will give plan planners options they did not previously have. None of this negates the U.S. capability advantage. All of it narrows the margin within which that advantage operates. The strategic picture that emerges from the production numbers is one of two industrial logics in tension. The U.S. approach produces fewer, more capable submarines that can operate anywhere on Earth and hold any adversary force at risk from beyond its own reach. The rival approach produces more, regionally focused platforms that can complicate any operation within a defined geographic perimeter and absorb attrition in a way that the U.S. production rate cannot sustain in a prolonged exchange. Neither logic is wrong. They reflect genuinely different strategic priorities and genuinely different assessments of where a conflict in the Pacific, if it comes, will actually be decided. The maintenance backlog problem runs alongside production and amplifies it. As of the most recent publicly available assessments, a significant portion of the U.S. attack submarine fleet is at any given time in some stage of maintenance, repair, or overhaul. The Los Angeles-class boats that predate the Virginia program are aging into a maintenance cycle where the work per hull is increasing. When a Los Angeles-class submarine like USS Annapolis or USS Helena enters extended maintenance, the yards that handle submarine work are absorbing that demand alongside new Virginia construction. The same workforce, the same dry docks, the same certified welders. The competition between new construction and maintenance throughput is a structural feature of the current industrial situation, not an aberration, and it is one reason why the new hull delivery rate translates only partially into net fleet growth. The operational tempo consequence is straightforward to state and difficult to absorb. If the available submarine fleet at any given moment is reduced by maintenance demands, and if new construction is not replacing retired hulls fast enough to maintain total force structure, then the submarines that are operationally available are deployed more frequently and for longer periods than the force was designed to sustain. That is where the human cost of the production shortfall becomes concrete. It is not an abstraction about industrial capacity. It is the crew of a Virginia-class submarine extending a deployment because the hull that was supposed to relieve them is 6 months behind schedule. Something about that specific dynamic, the way a supplier delay or a workforce shortfall in a Connecticut shipyard translates into extended time at sea for a crew in the Western Pacific, sits at the center of what makes this problem hard to communicate in terms of defense budget line items. Here is what is actually being chosen as of mid-2026 based on the available evidence. The Navy and the yards are pursuing the workforce expansion path, the long road, the slow ramp, with the expectation that throughput will approach 2.33 boats per year by the late 2020s, and potentially reach 3 by the early 2030s if the workforce pipeline performs as modeled. That is not a guarantee. It is a projection that assumes the apprenticeship programs deliver certified workers on schedule, that the supplier qualification efforts reduce sole source risk on the critical components, and that the yards do not face additional disruptions from labor action, materials, costs, or the kind of pandemic-era supply chain disruption that set the program back by months in 2020 and 2021. The AUKUS timeline is being managed through the rotational presence mechanism. U.S. submarines operating from HMAS Sterling beginning in 2027, providing Australia with access to the operational presence of Virginia-class boats before the transfer of owned hulls. That arrangement buys time for the production ramp without requiring transfers that would immediately reduce the U.S. operational fleet. It is a sensible bridge, and it does real alliance work in the Indo-Pacific. But it depends on the rotational presence, not degrading Pacific fleet availability to the point where the cure costs more than the disease. The Virginia payload module boats, the Block V and the coming Block VI, are where the capability argument reasserts itself. Each Block V hull carries the Tomahawk payload of multiple smaller submarines. The strike capacity per hull is significant enough that the capability loss from fewer hulls is partially offset by the per-hull capability increase. That argument is real, and it is relevant. It does not fully resolve the presence argument. A submarine providing persistent intelligence, surveillance, and reconnaissance coverage in a specific geographic area cannot be replaced by a more lethal submarine that is not there. But it does mean that the quality versus quantity trade-off is not simply 2-for-1 in either direction. The Los Angeles-class retirement timeline is the clock in the background of all of this. Those boats, some of them commissioned in the 1980s, are reaching the end of their service lives. USS Providence, USS Baton Rouge, USS Jacksonville. These are hulls that cannot be kept in service indefinitely by will or by supplemental appropriations. As they retire, the Virginia-class production rate determines whether the total attack submarine force holds steady, shrinks, or grows. At current production rates, the force is likely to experience a net reduction in the early 2030s before the production ramp catches up. The Navy acknowledges this. The question is how significant that dip is, and how much operational risk it creates in a period of elevated tension in the Western Pacific. The broader lesson of the production paradox, and there is one beyond the submarine program specifically, is that industrial capacity is a strategic asset that degrades silently and reconstitutes slowly. The United States spent the post-Cold War decades optimizing its defense industrial base for a world where technological superiority was assumed. Budget efficiency was the primary metric, and industrial mass was considered a Cold War relic. The workforce dispersed. The supplier base consolidated. The shipyard capacity that had once built multiple classes of submarines simultaneously contracted around the program of record. None of these decisions were irrational given the strategic environment of the 1990s and 2000s. All of them created structural constraints that are now binding at exactly the moment the strategic environment has shifted. Rebuilding that capacity is not a matter of political will. It is a matter of time, measured in 5-year workforce training cycles and decade-long shipyard investment programs. The decisions being made now will determine what the U.S. submarine force looks like in 2035. The decisions that will determine 2040 have not all been made yet. Comment yes or no. Do you think the production ramp to 3 boats per year is achievable before 2033? The gap between optimists and pessimists on this is wider than the official projections suggest, and the answer matters more than almost any other number in Pacific defense planning. So the paradox has an answer, and the answer is not satisfying in the way defense budget headlines usually are. The United States Navy has $30 billion in Virginia-class submarines under contract, the most capable attack submarine fleet in the world, and a political consensus that Pacific submarine presence is a strategic priority. None of that translates into more than approximately 2 boats per year because the constraint is not money and it is not political will. It is the compounding difficulty of building and sustaining the specialized human and industrial infrastructure that nuclear-powered submarine construction requires. Welders take 5 years to certify. Sole-source suppliers cannot be duplicated in a procurement cycle. Workforce pipelines cannot be accelerated by supplemental appropriations alone. The choice on the table is not really between 2 boats and 3 boats. It is between accepting the pace of a slow, durable rebuild of the industrial base, arriving at 3 boats per year in the early 2030s, with all the near-term operational risk that implies, or attempting to shortcut a process that does not have shortcuts at the cost of quality, safety, or both. Both roads have a price. The Navy appears to be choosing the former. Whether that choice is validated by the strategic timeline that the Western Pacific imposes is the open question. And it is one that production schedules, workforce numbers, and the retirement curve of the Los Angeles-class boats will answer before any policy document does. If you want to see how the surface fleet side of this equation plays out, specifically what the Arleigh Burke production line looks like against the same industrial pressure, that breakdown is next.